So let's go ahead. I think we're on page, where am I? I think page 7. So we hadn't done average value of the function yet. So what we're kind of finishing up this semester is things with definite integrals. So what an average value is, I'm going to show you what this formula does. And probably one of the easiest ways to explain this is just do this example 8, because it's very logical what it would be. So what I want you to do is let's go ahead and let's graph this. And all I'm having you do is graph f of x equals 5. Well, how do you graph y equals 5? That's a line that's horizontal, right? I'm using this example because it's easy. Okay, so let's go ahead, and all you need to do is just go up 5, and then you can draw a line that goes through like that. It's a horizontal line like that. That's not a very good horizontal line. There we go, something like that. You get the idea. Okay, so we're going through 5 like that. Okay, now what we're going to do is we're going to find the average value from 0 to 10. So let's just go out like to 10. You can just kind of do something like that if you want to. And it's pretty obvious what the answer would be. What's going on this is every value is 5, isn't it? So what would be the average of a bunch of 5s? 5, okay, so the average value is going to be 5. That's the reason I'm doing this example, because it's easy to interpret. So what we do is we do this integral right here. So I want to show you how to set this up. What we do is b is going to be the end point. A is going to be the beginning. What we're doing is we're looking at the average value of the function from 0 to 10, which is obviously 5. It has to be. So if we set this up, it'd go like this. We'd say average value is 1 over b minus a. So that's going to be 10 minus 0. And then you do the integral from a to b. So that's going to be 0 to 10. And then the function we're dealing with is 5 dx. So I just want to show you that this works in this case because it's an easy case to interpret. Okay. So what you would have is you'd have 1/10. And then we're going to do the integral 0 to 10 of 5 dx. Okay. All right. So what is the antiderivative of 5? 5x. Okay, so we got to kind of remind ourselves how to do these definite integrals now. So that would be 1/10. The antiderivative of 5 is 5x, and that's what gets evaluated from 0 to 10. Okay, so you write that like that. You put that bar to represent that you're evaluating that. Now what you can do is, there's more than one way to do this, but to me what's obvious is just reduce that to a half. Okay, so what we'll have then is we'll have 1/2. And then we're going to evaluate for the x, the antiderivative, after you simplify that's x, and then we're going to evaluate that from 0 to 10. That constant, you don't have to evaluate that, you just bring it out. Okay, what we were working on last week is when you evaluate a definite integral, which we're going to do a bunch today, you just plug the top number in, and that's just going to be 10, and then minus, and then plug the bottom number in, so you get half a 10. So what's the answer? 5, like we thought it would be, right? I mean, that's the only thing that would make any sense. So what the average value is doing is it's an integral, and it's finding the average of all those values. What's kind of bizarre about that is there's an infinite number of function values, but you can find the average with an integral. So that's how that works out. Okay, does that make sense what it did? Okay, now really what we're going to do on this is just learn how to use this formula and get comfortable with that. The rest of them, it's a little hard to tell what the answer is until you do work out that integral. So what we're going to do with this one, on example 9, I went ahead and gave you a graph. And I think the way this is going is I don't even know how I scaled this, but that's 0, and then out here somewhere, that may be ln of 2 like that. I didn't write that out, but I'm going to do this in the calculator here in a minute. Okay, let's start by just putting this in the calculator. Even though I've given you a graph, I wanted to show you a couple of things on this too, and just remind you of how you can check an integral on your calculator. So I'm going to put in e. You want to get your e key to come out, and then 2x, like that. And what we're going to do on this, the window, we're going to set up like this. we're going to be looking at the average value from 0 to ln of 2. So let's just put in 0, and you can put ln2 there if you want to. It's okay to do that. Okay, and it'll just change that to a decimal, and then it doesn't matter what the scale is. Let's scale that maybe by 0.1. That way it's going 0.1, 0.2, and then going up to about 0.7. Okay, I think let's go to 5. I think on the y we're going to go like 0 to 5, and then do a scale of 1 like that. Okay, so you want to get that window put in, and then graph, and it should give you what I gave you anyway. Okay, like that. So let's work out the integral, and what we're doing with this problem is we're finding the average value. If you look on your calculator, that was 0.69. So the average, I don't know, it's probably in here somewhere. So it's probably going to turn out to be, who knows, 0.4, 0.5, somewhere in there. You're going to have some smaller y values and some bigger values. So that average is going to be in there. Does that make sense? We don't know what until we work out the integral, okay? So let's set up the integral, and this should be a fairly easy integral to do. And what we're going to do with this one is average value. The formula, let's write that down first, is 1 over b minus a. Then you're doing the integral from a to b of f of x dx. So anytime you're asked to find an average value, you just got to set that integral up. Okay? What's a and what's b?
ln2.
A is 0, b is ln2. I'm using ln2 because it makes it easy. Okay, so what we have is 1 over b is ln2, a is 0, so you get that plugged in. Okay, then you're going to do the integral from 0 to ln2 of e to the 2x dx like that. So once you work that integral out, you'll have what the average value is then. Okay, now this one can be done by U substitution. I'm going to go ahead and do it that way, but I'm also going to give you a formula that's real helpful. It's real helpful to know how to do e to a power and just know the formula for the integral. So what I'm going to do is we're going to do a U substitution, okay? And we're going to let u be 2x. Now we're doing a definite integral, so we did a little bit of this last week, so we're going to need to review how you do definite integrals with U substitution. Tell me what du is. 2 times dx. Okay, so we got the u part right there. Okay, dx, we were hoping that du was dx, but it was 2dx. So what do? Divide by 2. You got to make it match. Okay, so we're going to divide that by 2, divide that by 2, and then dx is actually 1/2 du. So now everything's accounted for, see. Okay, I'm going to end up with e to the u and then 1/2 du, which is an easy integral to do. Now, what you have to do also, now we did a little bit of this last week, we're going to change the limits. These limits of integration, when you do a U substitution, you want to change the limits too, because it makes it easier to do in the long run. So what we do is let's start with the lower limit, 0. All you got to do is plug it in to this U substitution. So what you're going to do is just 2 times 0, still 0. That limit right there is not going to change. That's going to be the same. Okay? Now what you want to do is you want to plug the ln2, the upper limit, again into that U substitution. So what we're going to have is 2 times ln2. Okay, so you get 2 ln2. And now we're ready to get this integral all put together then. So we got everything accounted for. We have the u, we have dx is 1/2 du, and then our limits have changed to that. So what we do is we build this integral like this to get this put together. And then don't forget about the thing in the outside right here. So let's write down the average value is going to be 1 over ln2. Now our integral is going to go from 0, we got that, and it's not going to go to ln2 anymore, it's going to go to 2 ln2. Okay, like that. So that's 2 ln2. All right, now let's put together the U substitution. We'll have actually a very easy integral to do. Okay, so what do we have? We have e to the u. Remember, we let u be 2x. Okay, what was dx? 1/2 du. Okay, so you change that like that. Okay, that's what we worked out to get the average value. Okay, do you guys follow the substitution? Tell me. Everything. You got to follow every little piece of that. You got to change the limits also, and that's easy to do. All you do is plug that into 2x. Then the limits get changed along with everything else. Okay? All right, what could you do with this 1/2? It's constant. Bring it out. Okay, so we're going to do that. Okay, so we're going to have average value is 1 over, and then when I bring that out, that's just going to be 2 ln2. You're just taking 1/2 times 1 over ln2, you're multiplying straight across. Okay, what's the antiderivative of e to the u? E to the u, okay, so I like that. And then we're going to evaluate that from 0 to 2 ln2. So once we get done with the evaluation, we'll have the exact average value, then we'll just get a decimal to approximate. Okay, so here's what you'll have. You'll have the 1 over 2 ln2. Then you're going to evaluate the antiderivative. You're just going to evaluate that u at those limits of integration. So we're going to do e to the 2 ln2 minus e to the 0 like that. Okay, now we got to work this out. We're going to get an exact answer, then we're going to get a decimal on the calculator here. Okay, couple of things you got to do on this. This right here, one thing that you learned about ln's is this property. If you have a number in front of an ln, it can be written as the exponent. Because remember, an exponent can be brought down in front of an ln, so you can do that the opposite way. So you're going to have 1 over 2 ln2, and then we're going to have e to the ln of 2 to the second, and of course e to the 0 is 1, so we get that. Okay, so what we're going to have from here is 1 over 2 ln2, that will be e to the ln4 minus 1. And actually that's the exact answer to the problem right there. What I'm going to do on this is also just have you get a decimal answer on the calculator, so that's it. So that would be your exact answer. Now let's just do this on the calculator and see what we get. Should get something somewhere between 0 and 0.69. So I'm just going to put this in one step on my calculator like this. You got to be careful. You got to say parenthesis 1 over. You got to say 1 divided by, and this is where you got to be real careful, is that 2 ln2, you have to put that in its own parenthesis, or it isn't going to evaluate it right. I see students mess up on that part of this problem a lot. So see, that's how you get that. All right. Then what I'm going to do is have a new parenthesis, and then I'm just going to go like this. I'm going to go e raised to the ln4. Okay, like that. Got a close parenthesis, and then bring that down and do minus 1 like that. Okay, that's the way to do it in one step. But this thing right here, you have to go 1 over parentheses 2 ln2. You have to. If you don't do that, then what the calculator is going to do is it's going to do 1/2, which is 0.5, and multiply it by ln2. That's not what you want. You want 1 divided by the result of that. So let's see what we get here and see if this is logical. Okay, that is not logical. So I must have put something wrong in my calculator somewhere. Well, I don't see anything wrong either. Let's see. A little mistake I'm not seeing on the integral. So let's do this. You got this in your calculator. So what I'm going to do is I'm going to go second calc, like I've taught you, option 7. You want to go through that. The lower limit is 0, because we're doing the original integral, not the U substituted one. So we're going to go 0. Upper limit is going to be ln2, like this. Now this is how you could do this totally numerically. Now that's going to give the value of the integral. That's not giving the average value. What you would have to do with that is multiply that by that 1 over ln2. That thing's kind of slow. Okay, so that's giving, what is that, 1.5 is what that's giving. Okay, so I'm going to just kind of write this like this, and then I'll look over this one more time and see where I made a mistake. So that right there is 1.5. Okay, and then you're multiplying that by 1 over ln2, and then that should give you the average value. So if I do that, here's what I'm going to get. I'm going to have 1.5, then I'm going to divide that by ln2, and then this should give the average value. That does not make any sense to me. Oh, yes, it does. Here's why. Here's why. I'm thinking about the wrong thing. This is the average value is the function value. I was thinking of x values. It's actually the average of the y values. So that answer is correct. Whatever I had on there is correct. I was thinking about the wrong thing, so I didn't do anything wrong. So let's round that off as 2.16. Then I want to show you this basically. This is what you need to understand. So if I was to trace at these values, like if I trace at 0, I have a function value of 1, okay? If I trace at the end of this interval at ln2, what you end up getting is you get 4. So you're looking at values between 1 and 4. Is that more logical now? It should be, okay, because what I was saying was I was thinking the answer was going to be between 0 and 0.69. That's wrong. You're looking at y values, so I should have been paying attention to that. So that is the right answer of the problem, 2.16, okay? All right, so that's how you would do the U substitution integral, which to me is the hardest part of the problem, is the U sub. The setup of that's not hard to do, okay? All right, you guys got any questions about that and what I did? U sub is what I can tell some of you are having some trouble with, and you got to be, anytime that you have a E, then you're going to let U be the exponent. That's always going to be the way it is in this class. You're going to have to let U be that exponent. Okay, let's do a couple more things on this next page to finish this up. So these are some applications. This is a example 10. This is a supply equation, and we're going to find the average price from 20 to 30. Okay, and let's just do this, and then we'll look at a graph to interpret this. Okay, so the average value, again, let's start, just write down the formula, is 1 over b minus a. Then you have the integral, in this case it's going to be s of x dx going from a to b. Okay, so tell me what a and b are. That's the first thing. A is 20, b is 30. Okay, so let's go ahead and set this up then. That's going to be 1 over 30 minus 20, and we're going to do the integral from 20 to 30. The function is 10 e to the 0.05x, okay, and this is a U substitution again. So if you didn't quite catch what I was doing in the last one, this is going to be the same thing primarily. So I'm going to have 1 over 10 integrating from 20 to 30, and then what can I do with this 10? Bring it out. Yeah, you might as well just bring that out now. Okay, so I'm going to bring that out now, and if I do that, that's going to really cancel that 1/10 out. Okay, so that will kind of make it a little easier. So I just bring that out like this. Then I have e to the 0.05x dx. Okay, everybody good so far? Okay, the first thing is you got to know how to set it up. Okay, now this is a U substitution. That's where some of you are struggling. That's always the way it is. What would I set U equal to? I said that a minute ago. Whatever the exponent is, exactly. So you have 0.05x, or 0.05x. Okay, so set it equal to whatever that exponent is. So that's U. Now, what is du? It's the derivative, which is what? 0.05 dx. You know, the derivative of something times x is the number in front. Okay, here's where some of you, I can tell, don't understand. What were you hoping du was? dx. It isn't. So how do you make this become dx? This right here. You divide. Okay, so what you're going to do is you're going to divide both sides by 0.05. Now it's going to match the way it's supposed to. See, dx is going to be this. It's going to be du over 0.05. Now everything matches. You're going to have e to the u times du over 0.05. Okay? Now you got to change the limits. That's the other thing you have to pay attention to. So you got to do the limits. Okay? The first limit's 20. Where do you plug it in? You plug it into your U substitution. Okay? So what you're going to do to change that limit is you're going to do 0.05 times 20. Okay, you can do that on a calculator if you want to. What is that? 1 or 0.05 times 20? Yeah, that's 1. That's what I thought. So that's 1, okay? So the limit is now 1. It's no longer 20, it's 1. So I'm going to change this to 1. Okay, then I do the upper limit, which is 30. I do the same thing. I do 0.05 times 30. That's probably 1.5, I think, just to make sure. Okay, that's 1.5. Okay, so that upper limit is going to be 1.5. Okay, so what I've got now is I'm going to have e to the u. dx is going to become this, and my limits are going to go 1 to 1.5. Tell me if you follow that. That's where I can tell that students struggle. Yep.
How do you know when you're supposed to change the limit?
Okay, because it's a definite integral and you're doing a U substitution. Okay. If you weren't doing U substitution, you would leave them alone and just do your integral. And that would be on the integrals you can pretty well do in your head, like power rule and stuff like that. Okay? All right, well, let's put it together. Let's see what we got. So what we would have then is the 10s cross out. So you would end up with this. You would have the integral from 1 to 1.5. Okay, and what you're going to have is e to the u, and then dx gets replaced with du over 0.05. Okay, what do you do at the 0.05? Bring it out. It's a constant. Okay, see, that's a 1. So that thing comes out, so you're going to have 1 over 0.05 times the integral from 1 to 1.5 e to the u du. And I've done a bunch of substitution. That's what you've got to follow on U sub, is how to get everything changed. Now it's easy. What is the integral of e to the u? Antiderivative. What is it? E to the u. Okay, that's why we did what we did. So you're going to have 1 over 0.05 and then e to the u. That's the antiderivative. But now you evaluate from 1 to 1.5. You don't have to plug that u back in because you changed the limits of integration. So to finish the problem, you're going to do this. You have 1 over 0.05. Then you're going to do this. E to the 1.5 minus e to the 1. Okay, that's what we call the fundamental theorem of calculus, which always means that you just take the upper limit, lower limit, and subtract. Okay, that's how you evaluate a definite integral. Now this one right here is probably wise to just get the answer on the calculator, okay, which you're going to do a lot of times. That's an exact answer right there. So let's just do this in the calculator. So I'm going to go like this. I'm going to go 1 divided by 0.05. And notice I'm putting that in parentheses to get that taken care of. Then in a new parenthesis, I'm going to do exactly what's in here. I'm going to do e to the 1.5. Okay, then minus e to the first, which of course is just e. Or you can put the e to the first in if you want to, like this. Okay, and that should do it. Okay, that should give you a decimal answer, and then we'll see if this makes any sense. So I'm going to round that to 2 decimals. That'd be 35.27 would be the approximate average value of that function. Okay, now that's the calculus. Now I'll show you how you can kind of make sense of this. Okay, how does the U sub look? That's what I can't tell with students. When you've got a U sub, you got to change those limits, and that's not a hard thing to do. It's just plugging the original limits, 20 and 30, into that U sub. Okay, you got to do that, and that way you don't have to. You just do the U integral and then evaluate it. That's it. Okay, yes.
You also you go from e to the u, and then you plug in your limits, your 1.5 and your 1.
Okay, so what I'm doing here, I think you're talking about, okay, I've got my U integral built.
Yeah.
Okay, now I'm doing this basically. When you do a definite integral, we learned last week the fundamental theorem. It just says do the antiderivative of e to the u. That's e to the u. Okay, if it was something else, so like if it was 1 over u, it would be ln of u. Okay, then you're just evaluating the upper limits. You're doing e to the 1.5 and then e to the first and subtracting.
So how come we're not plugging in your 0.05x for your u?
Well, see, we changed the limits. That's where we got the 1 and 1.5 is from changing those original limits 20 and 30. That way I don't have to plug that u back in. What you're used to doing if you don't have a definite integral, you're used to plugging the 0.05 back in.
Yeah.
Reason we don't do that is because we changed the limits so that we don't have to do this. you could also do this. You could do the integral from 20 to 30 of e to the 0.05x. That's what you're thinking about, is that. So if you plugged the u back in, then you wouldn't change the limits. You can do it that way if you want to, but it's usually harder. It usually simplifies it if you just change the limits too. Okay? All right, does that make sense?
Yeah, it does.
Okay. Okay, let me show you kind of what this problem means. And let's do this on the calculator, just to kind of help you understand this a little bit. We're going to put in 10, and let's see, e to the 0.05x. All right, we're going to graph that, and we're going from 20 to 30. So what I'm going to do is I'm going to do this. I'm going to graph from 0 to 30, or actually I'm going to go a little further. I'm going to go 0 to 40. Okay, that's just my decision. You don't have to, but it's a good idea when you're doing a definite integral on your calculator to go a little higher than whatever those limits are. You'll get errors if you don't do that sometimes. Okay, our answer was 35.27. That's a y value. So what I'm going to do is for the y's, I'm going to go like 0 to 100 and just kind of try it that way. And then what I want to do is show you how you can check your answer with your calculator. Okay, so I've got everything kind of set up. If you want to do this with me, and if I graph this, okay, we're looking at the average value. Okay, now I want to show you kind of what happens on this too. Is if you did this original integral, now the original integral was 20 to 30. Okay, we have in our graphing calculator right now, we're graphing this thing. So if you went second calc and then did your option 7, okay, like this, your lower limit, I'm going to do 20. So I'm not doing the u integral, I'm doing the original integral. I'm going 20 to 30, and I'm going to do that. Okay, that's going to shade that in. And that's going to give you the area under the curve from 20 to 30. And that is, I'm seeing on my calculator, 352.68145. Well, the other thing is, you got this 1/10 right here. So if you take this thing right here and multiply it by 1/10, you should get what we got. Okay, so what I'm going to do on that is just clear this off and then do, and you can divide by 10. So if you do 352.68145, if you divide that by 10, all it's going to do is move the decimal over to the left one anyway. And it's going to give what we got, see. Okay, so you can do this on the calculator. You can check it. You can, I want you to learn how to do the U substitution, obviously, but you can go through and verify your answer on this. It's not a hard thing to do. You can do this integral, get the answer like I did here, and then multiply by that number in front. Does that make sense? Okay, so it's doable. Okay. All right, let's do this last problem. This one doesn't have anything to do with average value. So what you're doing on this one is, this is an oil company, and this is a rate of, I guess, of the field production. Okay, gives this. You're given a range from domain 0 to 20. And there's two parts of this problem. It says how many barrels of oil will the field produce in the first 10 years of production, and then from the end of the 10th year to the 20th. Now this is an integral. What you're doing is you're totaling stuff. So the first part of the problem, it doesn't say anything about average value. It just says, you know, what's the total on that. So what we're going to do is we're going to do the integral. The first 10 years, what would you integrate from? From where to where?
0 to 10.
0 to 10, exactly. Okay, so we're going to do this integral. And then we're going to do the function 100 over t plus 1 plus 5. So we're going to do that integral first. And then the second part of the problem, it says from the 10th year to the 20th year. So what's the difference? Now you're just going to integrate from 10 to 20. Okay, so we're going to work out two integrals here. These are really things that you could do without U substitution if you were kind of careful about it, or you could do it with U substitution. I'm going to do U sub because that's what you guys need help with, I can tell still. Okay, so here's what I'm going to do on this. If you think about this, you could break this up like this. If you wanted to do a U substitution, you would probably want to do u equals t plus 1. And you would probably, before you do that, you would want to break this up into two integrals. Okay, so I'm going to do this to start with. We're going to do integral from 0 to 10 of 100 over t plus 1 dt plus the integral from 0 to 10 of 5 dt. Now, the integral of 5 dt you can do. Now, this one right here, you could actually do this without U substitution. Let me show you why. If you have something, what if you had this instead? Okay, what if you just had 1 over t dt? Then what is the antiderivative there? That's ln. Okay, so I bet we're not much different. Okay, that would be ln of t. Okay, what do you think this might be? It's ln of something. Forget about the 100 because that's a constant that can come out. What if you had integral of 1 over t plus 1? What do you think it might be? ln of t plus 1. Okay, well, what you want to do is you want to find out. Sometimes problems are easier enough that you don't have to do it by that. How do you tell you're right? Take a derivative. That's how you check the answer to an integral, right? So if you did the derivative of this, you would have 1 over t plus 1, and then the derivative of what's inside would be 1, so it would be the same, wouldn't it? Okay, so that's it. So we don't have to do U substitution. You could, but it's just as easy on this to know that that's going to be ln of t plus 1. Okay, so let's do it that way. So what we're going to do is bring the 100 out. Now we're going to have the integral 0 to 10 of 1 over t plus 1 dt. And then we're going to do this. This way we don't have to do U substitution. Okay. Now how do I know that? Well, if your variable is in the denominator, sometimes there's a good chance it's an ln. If you didn't see that, you could do U sub. Okay, so let's do this now. This would be 100. We said, what was the antiderivative of 1 over t plus 1? ln of t plus 1. Then that's going to get evaluated from 0 to 10. Okay. What's the antiderivative of 5? 5t. So we're going to have plus 5t evaluated from 0 to 10 like that. Okay. All right. Now we just kind of plug it in and do the calculations. So if you do this first part, we're going to do two different parts on this. So we're going to do this, and then we're going to do those. Okay. So what we're going to do on the first one is 100. You're going to do ln of 10 plus 1. You plug the upper limit in to get 10 plus 1, and then minus, and then plug the lower limit in to get ln 0 plus 1 like that. Okay, then we got the second part of the problem, so we have plus 5, and then I'm going to plug this in to get 10 minus 0. See, the 5's a constant, so what you're doing is plugging in to the 10 and then the 0 like that. Okay, that's how you evaluate the integral then. So if you work this out, we're going to have 100 ln of 11 minus ln of 1, and then 5 times 10. Okay, now we don't want that answer. We're talking about money here, or rates. It's better to deal with just some sort of a number. So what I'm going to have here is 100 ln 11. ln of 1, what's ln of 1? 0. And then we have 50. And then from here, I'm just going to do this on the calculator to get a approximate answer from here then. Whoops. Okay, so I'll just put this in exactly like this. 100 and then ln of 11. Don't worry about the 0. Plus 50. Okay, and then that will give 289. Let's just round to one decimal, so that'd be 289.8 would be that rate. Okay, and that should be the answer. Now the next one, I'm not going to do the next one because it's the same thing. I just wanted to have you set that up. That would just be going from 10 to 20. It would be the same problem, except you get a different answer because you're going from 10 to 20 instead of 0 to 10 like that. Okay. That's not U sub. Does that look okay? How I did the definite integral? Everybody following that okay? Any questions? Okay. All right. Okay. All right.